Section 4.2, trig functions and the unit circle. Be careful with these definitions because this is for a unit circle. A unit circle is a circle that is 1 unit in radius. So all the way around that circle is just 1 step away, depending on what that unit happens to be. So when we define the unit circle or the trig functions as with respect to the unit circles, notice that we're 1 step over, 0 steps up at our initial side. This value would be 0 over 1 up, -1 over, 0 up, and 0 over 1 down. So this is a unit circle. So these definitions will change when we're talking about trig functions of any angle. Okay, they're going to change slightly. So we're going to let t be a real number and let xy be the point on the unit circle corresponding to t. Remember the other day when we had that sector, that radius wrap around? That's what's going on here. We're saying we're t units over and we're wrapping this around. Okay? That's our sector length basically. And this is because this is a unit circle that the sine of t is y. Okay, later on your foldable we'll be changing that to y over r. Okay, but not today. So the sine of t is y, because if you look at it, the y value is our height, isn't it? Okay, our y value is our height, and our x value is the adjacent. So the opposite adjacent hypotenuse, the sine of t is going to be the opposite over the hypotenuse, and the hypotenuse on a unit circle is 1. Okay? The cosine of t is the adjacent, bless you, over the hypotenuse, and the adjacent to this angle is x. And the hypotenuse here is 1. Okay? The tangent is the opposite over adjacent. Opposite's y, adjacent is x. So it'll be y over x. And that will be true all the way through. These values are going to change when we're no longer dealing with a unit circle. Tangent and cotangent will stay the same. Okay? So when we want the cosecant of t, we find the reciprocal of y, 1 over y. Secant of t, reciprocal 1 over x. And cotangent of t, the reciprocal of tangent, x over y. So far, so good? Okay. So here's our unit circle. You can get your unit circles out. You have your little spinners. Yeah, absolutely. We're going to add to it today. Okay? So today we're going to add to these guys. We want these special angles, okay? And we want to know their values. So remember, we had 30 degrees here, and this was pi over 6. Okay? What's the sine of 30? 1/2. Okay? We just said that the sine is the y value, right? So this is the point something 1/2. Okay? What's the cosine of 30? Square root of 3 over 2. We just said that the cosine of a unit circle is x. So square root of 3 over 2 is this guy's value. So we have an ordered pair here. This is square root of 3 over 2 over and 1/2 up. Mm-hmm. It will always be this way, even if it's not a unit circle, okay? Because those values are going to be, we can stretch it out and so forth, okay? So how did we get that again? So we just said on the last slide that the sine of theta or t on a unit circle was the y value, okay? And we said that the cosine of t on a unit circle was the x value. And at this point, we are at 30 degrees. So the sine of 30 was 1/2, so y has to be 1/2. And the cosine of 30, yes. You'll want sine, cosine, and tangent memorized for 30, 45, and 60. And then you can get everything else from there. Everybody good so far? Okay. What was the sine of 45? Square root of 2 over 2. So the y value is the square root of 2 over 2 for 45. Pi over 4. What's the cosine of square root of 45? Square root of 2 over 2. So this is the coordinate square root of 2 over 2 right here. Okay. What's our next special angle we have to know? 60, which is equivalent to pi over 3. Good. And let's do cosine first since we're talking about x first. What was the cosine of 60? And what's the sine of 60? Okay. So far so good? They're co-functions, so these two will be flipped at the 30 and 90, and they'll be the same at the 45s, okay, in the first quadrant. We'll have some sign differences in the other ones, okay? What's our value here? Everybody knows that's 1 over 0 up, right? On a unit circle. What's this one's value? 0, 1, and that's 90 and pi over 2. Okay? What's this measure? 120 and, sorry for the degree angles, and what's the equivalent to 120 in radians? 2 pi over 3. Or over, yeah, 2 pi over 3. Okay? Now, this is what kind of an angle? Well, if I drop it down, this is actually a 60-degree angle, isn't it? Everybody agree with that? So what's the cosine of 60? But are we positive or negative here? Okay. And what's the sine of 60? Square root of 3 over 2. And it's positive because the y value is positive. Okay. 45-degree angle in the second quadrant is going to be 3 pi over 4 and 135. So negative for the x value. Yep, square root of 2 over 2. Square root of 2 over 2 for the y value. Okay. This is a 30-degree angle in the second quadrant. Its value is 150 in degrees and 5 pi over 6. Okay. So what's the cosine of 60? Sorry, cosine of 30. It's a 30-degree angle, so cosine of 30, square root of 3 over 2, right? Positive or negative? Because we're on the left, we're going to the left. And 1/2. Okay? this coordinate point, or what's the ordered pair? -1, 0. This is our 180, or pi. Okay. So this down here is going to be what kind of an angle in the third quadrant? 30, 45, or 60? 30. So this is a 30-degree angle. What's the cosine of 30? 1/2. Cosine of 30, square root of 3 over 2. And we're negative. And what about the sine of 30? 1/2, positive or negative? Negative. Okay. And this is a 210. And they're both negative, sorry. Negative square root of 3 over 2 and negative 1/2. Sorry, it's tiny. I should have write bigger. And this is the equivalent of, what was it? 5 pi over 3? .45 is always square root of 2 over 2, square root of 2 over 2. They're both negative. And this guy is, how many pi over 4? Right? I always say 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. This is this is our 215. Okay, and then we've got 225. 225 is right. And then we've got 240. It's a 60-degree angle in the third quadrant. 4 pi over 3. And what will its ordered pair be? Radian is 0. In this quadrant, it should be 5 pi over 3, I believe. No, 7 pi over 6. My fault. I was doing the 7 pi over 6. I hate this eraser. Thank you for catching it. There. Try to do two things at once, multitask. Okay? Everybody good? So what's this one's ordered pair going to be? Okay. And then at 90, or I'm sorry, at 270, how many, or what's our ordered pair going to be? We're 0 over and 1 down, right? Okay. And we can keep filling this out, but for time's sake, let's just do the ordered pair since you've got the whole circle filled out. Over here at our 60-degree angle in the fourth quadrant, our cosine of 60 is 1/2, but it's positive now, and negative square root of 3 over 2. Cosine here, negative square root of 2 over 2, or positive square root of 2 over 2, negative square root of 2 over 2 for this guy, or to the right. So our x value is positive, our y value is negative. And then square root of 3 over 2 and 1/2 with the negative. Okay? So those can help you. Use them as a reference, but be able to derive them, understand where they come from. And remember, we don't want to use this as a crutch. We use it as an aid, and then work our way to the point where we can do this without our unit circle. Okay? All right, keep it moving. Evaluate the 6 trig functions at each real number. Okay? So t is 2 pi over 3. 2 pi over 3 was this guy up here. Okay? 2 pi over 3 is a 60-degree angle, isn't it? What's the cosine of 60? 1/2. Positive or negative? The y value is, or sorry, the x value is negative, right? Sine of t, sine of 60. Square root of 3/2 is the y value positive or negative here? Positive, right? Okay. Tangent. What's the tangent of 60? Square root of 3. Positive or negative? We're taking this over this, so it's going to be negative. Yep. Okay. The y value, yep, is sine over cosine, or y over x. So what I do is I say, okay, 2 pi over 3 is here, right? Everybody was okay with that, okay? And then I honestly just say, well, this is a 60-degree angle. Anytime it has a 3 in the denominator, it's been reduced, it's a 60-degree angle. So if you look at your unit circle, we just talked about it, right? If you look at that, we're at negative 1/2 and square root of 3/2. Okay, and the sign is the y. Not on the test, but for the quizzes, yes. Okay, but you have to be able to quickly, and I'll give you a unit circle on your test. You won't have to necessarily fill it all out intentionally, but it'll be there so you can jot things down. I won't ask you to fill the whole thing out. You may just need part of it. Okay, and actually, I think on your quiz, I don't know if I want you to use it either. Okay, but you'll have some practice before. Yeah, a blank one. Yes, absolutely. Yep, just not a filled in one. And you won't necessarily be requested to fill it all out, just the portions that you need as a reference. Okay, everybody good with that one? 6 trig functions, then we find the secant, cosecant, and cotangent. So cosecant, right, because when we flip it, the secant, yep, and the cotangent, yep. Okay, so far so good? Okay, this one, t is 4 pi over 3. Again, going to be a 60-degree angle, but where is it at? Lower left. So now you have to do the same thing, but you'll change your signs accordingly. Okay? Because now your x is going to be negative, and your y is going to be negative. Okay? So sine is the y, negative square root of 3/2. Cosine is the x, and that's going to be a negative 1/2. Tangent is the y over x, so that's going to be negative or positive this time, because negative over negative is going to be positive. And then flip. In this case, because they're both 60 degrees, yes. Okay, and I know it's a 60-degree angle because my denominator is a 3. I know it's a 45-degree angle if my denominator is a 4, and I know it is a 30-degree angle if my denominator is a 6. Okay, so that's the shortcut for those. Okay, if your denominator is a 3, it's the biggest one. It's a 60-degree angle of those special right triangles. If your denominator is a 4, then it's the middle one. It's the 45. And if your denominator is a 6, then it's going to be a 30-degree. Okay? And then you just have to figure out which quadrant so you get your signs right. Okay? We have about 4 minutes, so I got to keep moving. Do I need to go finish these? You're okay with the quadrant one? 2 pi is right here, right? 1 over 0 up. So you got your y's and your x's. Okay? 2 pi's all the way around. So that's your xy. So your sine is going to be the y, cosine is going to be the x, and tangent's the y over the x. Okay? And undefined if we're dividing. Yep. So sine here is your y, cosine is your x, tangent is your y over x, but the secant or the cosecant is undefined because we can't divide by 0. The secant is going to be 1, and the cotangent is also going to be undefined. Okay? All right. We'll come back and talk about domain and range of the sine and cosine. But have you noticed something about sine and cosine? They're opposites of each other on the they're cofunctions, right? Do they ever get really big, or are they always decimals? Always decimals, right? They're numbers between 0 and 1, including 0 and 1. And so that'll be their domain and range. Right. Your domain will be all real numbers, right? Because we can keep going around and around and around the circle. But the range is going to be between 0 and -1 and 1. Okay? So we'll come back and talk about even and odd functions and the rest of this. Okay? Try to do some of the assignment. If you get to something we haven't covered, stop. Okay?